So here we have a problem where it says let P be a point on a graph x squared minus 8. This of course is a parabola shifted 8 units down. Express the distance from P, from a point on that graph, to the point 0, -1 as a function of x. Okay, so just as a refresher, if I were to plot this, right, x squared minus 8, if I come down 8 units, that's going to be a parabola. Just shifted down 8 units, okay? Now I want to find the distance between any point, we'll call that P. Now remember, P is just going to have some xy coordinate. Okay, some xy coordinate, but we can replace the y value with x squared minus 8 in a moment. We'll do that. I want to find the distance from P to the point 0, -1. Well, 0, -1 is somewhere here on the y-axis. And so I want to find the distance. Now, the distance will be different for different points, right? This point up here on the right might be further away than a point down here on the right. And so every point I choose will have a different distance to the point 0, -1. And so I want to make an expression, a formula for the distance in terms of x. Okay, well first of all, we're looking for the ordered pairs 0, -1 and x, instead of xy I'm going to use x squared minus 8 for the y. Alright, so these are my 2 points and I want the distance between them. So my distance is going to be the square root of, now remember the distance is x2 minus x1 squared plus y2 minus y1 squared. Okay, so the x's, the difference in the x's are x minus 0 squared, and the difference in the y's would be x squared minus 8, that's the first one, minus -1 squared. I'm putting a lot of things in here. This is my y2, this is my y1, I subtract them, okay, and then square that. So now I simplify this expression. So d is the square root of, well, x minus 0 squared, that's just x squared, that one's not too bad. This one simplifies, -8, this would be a +1, be a -7. So this would be x squared minus 7 all squared. Okay. Now if I expand x squared minus 7, squared, sorry, that would be x squared minus 7 times x squared minus 7, and then you would distribute that. I'm not going to go through all of the detail there because it's like a perfect square trinomial. It would match up one of the formulas on your mathematical property index, where you take the first term and square it. So the distance is, so the first term squared would be x to the 4th. Then you double the product of the 2 terms, so that would be minus 14 x squared, and then you square the second term, which would be a plus 49. Okay. And then you combine the 2 like terms after that, and so that you get a minus 13x squared. So our formula would be square root of x squared, x to the 4th minus 13x squared plus 49. Okay, and that would be then the answer to our question. So this is the distance as a function of x from a point on the graph to the point 0, -1. Now, I can use this function to then find particular distances for particular points. So, let's erase some of this. Okay, now let's say I wanted to find the distance when x is equal to 0. We'll go with 0. When x is 0. Well, the distance when x is 0, gives me the point down here at -8. Now the answer, just looking at the graph, should be 7, right? Because it goes from -1 to -8. But let's plug it in and double check. So what I'm going to do is plug in to the function. So d would equal the square root of 0 to the 4th minus 13 times 0 squared plus 49. That term drops off, that term drops off. It's really the square root of 49, which indeed is 7. That matches up with the picture that I drew there. Let's try another one. Let's say when x is equal to, I don't know, maybe a value of 2, right? So if x is 2, let's see what happens using this formula. So find d when x is 2. So I plug in the 2. I get 2 to the 4th is 16. 2 squared is 4. So I get 16 minus, well, 13 times 4 is, what's that, 52? So the distance here is 16 minus 52 plus 49. Let's do some of this. And let's see, that distance, 16 minus 52 is, well, this distance here, this is -3. And 16, that'd be what, 13? So that would be the square root of 13. So the square root of 13 would be the distance between the point 0, -1 and the point of the graph at 2 units. Okay, so probably somewhere over here. That would be reasonable. Okay, and so you can see how to find those distances just by plugging in the corresponding x value. Okay, and then you can, here's something kind of interesting. You can actually plot the graph of this function. You can go to your y equals on your calculator. So you go to the y equals button, and then you can plot this graph. I'm just going to plug in square root of x to the 4th minus 13x squared plus 49. Oops. Okay, I made a little mistake in typing that in. Part of it came out of my root. Okay, so you want to be careful that the whole thing is under the square root. I hit enter, and then I'm going to go to zoom. I'm going to go down to standard, number 6. It probably isn't going to give me, oh, that gives me a decent graph. There's my graph. Okay, now the distance is just going to be, oh, it is positive. Yeah, okay, that's fine. There is some symmetry with respect to the y-axis on that, and that makes sense because the distances should be the same on the x and y side, or on either side of the graph. Sorry, x and y, I don't know what I'm talking about there. On either side of the graph, the distances would mirror each other. And so if I wanted to, let's say, find the point at which the distance is the smallest, so what point on this graph is closest to the point 0, -1, I can find that by finding the minimum on this graph. In fact, there's 2 of them, 1 on each side. To do that, you hit second calculate. We've seen this in other videos before. Go to the calculate menu and go down to the minimum. And I'll do the one on the right. I need the left bound, the right bound, and a guess. And because I've done this on another video, I'm not going to show all the details just to speed things up here. And I get a point at about 2.3 0.55 roughly. So so the point that has the shortest distance is approximately 2.55 comma 2.60. Okay, so right around there. Now I rounded those off, but that's pretty close to the point. And of course on the other side it would be symmetrical because of the symmetrical shape of that graph. So you'd have negative 2.55. This is y-axis symmetry, so the x value changes sign and the y value doesn't. So those would be the 2 points that would be closest to the point 0, -1 on the graph of x squared minus 8.